Welcome to Unit 5. In this unit, we will learn more differentiation techniques. That means that we'll look at more shortcuts so that we can calculate derivatives more quickly. This is Unit 5, Lesson 1, Chain Rule. To understand chain rule, let's look at this thinking question. If Yasmin makes twice means 2 times, as much money as Uriah, and Uriah makes thrice means 3 times, as much money as Jimena, how much more money does Yasmin make than Jimena? Well, intuitively, if Yasmin makes twice as much as Uriah makes 3 times as much as Jimena, then Yasmin makes 2 times 3, which is 6 times as much money as Jimena. For example, let's make the text smaller because we'll need the space. Okay. For example, if Jimena makes $10, well, Uriah makes 3 times as much. That means Uriah makes $30. And since Yasmin makes 2 times as much as Uriah, that means that Yasmin makes $60. Okay? Now we're going to put this in calculus notation. First of all, let's define some variables. Let's let y, I'm going to use lowercase y, is going to be the amount of money that Yasmin makes. U, lowercase u, will be the amount of money that Uriah makes, and not surprisingly x, because Jimena is Ximena. X is the amount of money that Jimena makes. Okay? When we say that Yasmin makes 2 times as much money as Uriah, what we're really saying is, in calculus notation, that dy, that's Yasmin's money, over dx, that's how much dy over du, that's how much money Uriah makes, is 2. So we can write it as dy over du equals 2. Next, it says Uriah makes 3 times as much money as Jimena. What that is saying, oops, let's move that, is that Uriah du, the amount of money Uriah is making is du. Uriah makes 3 times as much money as Jimena, so du, let me write this better, du over Jimena is x, so dx is equal to 3. Okay? And we concluded from this that therefore, Yasmin makes 6 times as much money as Jimena. Well, to write that in calculus notation, Yasmin makes 6 times as much money as Jimena. That would be Yasmin dy over Jimena dx. That equals 6. And we know that the 6 times comes from 2 times 3. In other words, what we figured out is dy over dx is equal to dy over du times du over dx. Okay? Dy over dx, that's the 6. Dy over du, that's how much more money Yasmin makes than Uriah. That's 2. And du over dx, well, Uriah makes 3 times as much money as Jimena, so that's 3. So again, dy over dx equals dy over du times du over dx. It kind of works out that you could do it like this. You can say, oh, the du's cancel. I mean, strictly speaking, you can't really cancel them because dy over du is really one term. But it works out. you can think of it that way. I mean, dy over du is times d over dx does happen to be dy over dx. There's a name for this. This dy over dx equals dy over du times du over dx. That's called the chain rule. Why is it true? Well, it's just, if Yasmin makes 2 times and Uriah makes 3 times as Ximena, then Yasmin makes 6 times. That's why the chain rule is true. Okay. Chain rule can be written in different forms. So again, Yasmin makes 2 times as much money as Uriah. dy over du equals 2. Uriah makes 3 times as much money as Ximena. du over dx equals 3. And we saw earlier that we've shown that dy over dx is dy over du times du over dx. But there are other ways of writing this chain rule. For example, you can write it this way. So dy over dx is really just the derivative of y with respect to x. So you can write it as y prime x. Okay. dy over du is the derivative of y with respect to u. So that's y prime of u of x. Okay, that's dy over du. And then du over dx is the derivative of u with respect to x, which is u prime of x. In other words, dy over dx is just y prime x. dy over du is y prime of u of x. And then du over dx is u prime of x. Okay. Another way of thinking about this is just the derivative of y is the derivative of y in terms of u times the derivative of u in terms of x. Okay. Some examples will hopefully help make this more clear. Example 1. So that's the chain rule. So again, just to make clear, 2 ways of writing a chain rule that we have shown so far before we move on. One way is dy over dx is equal to dy over du times du over dx. Or we can write it as y prime of x is equal to y prime of u times u prime of x. Okay. So example 1. Let me move the chain rule to this side. Okay, I'm just going to write them down so we can refer to the chain rule. I'm going to write it in both forms. dy over dx is dy over du times du over dx. And the second one is y prime is equal to y prime of u times u prime of x. Okay? Alright, example 1. A of x is equal to cosine of x squared. Okay? Well, in this example, cosine of x squared, we can look at it as u is x squared. So that means that a of x is just a of u. So u is x squared. Therefore, the derivative of a prime x is just, well, what's the derivative of cosine x? The derivative of cosine x is negative sine x. So the derivative of cosine x squared would be negative of sine of x squared. That's the derivative of y with respect to u part times the u prime x part. Well, inside we have x squared. So the derivative of x squared is 2x. Okay. So if a of x is cosine of x squared, then a prime of x is negative sine of x squared times 2x, which is equal to negative 2x times sine of x squared. That's it. In terms of the first notation here, what we're really doing is, well, instead of using dy over dx, we can do dA. We're really doing dA over dx is dA over du times du over dx, while u is x squared. dA over du is the negative sine x squared, and du over dx is 2x. Okay. All right. Example 2. b of x is cosine square x, which just means cosine x squared. So the square of cosine x. So cosine x times cosine x. Well, b prime of x. So u is really x. So u is really cosine x in this problem. What's the derivative of x squared? The derivative of x squared is 2x. So the derivative of cosine x squared will be the 2 times cosine x. But then we have to multiply by the derivative of cosine x, which is negative sine x. So the answer is negative 2 cosine x sine x. So again, we just take the derivative of the main part, which is u squared. That gets us the 2 times u. And then the derivative of the inside, cosine x, the derivative is negative sine x. So we have negative 2 cosine x sine x. Another way of thinking about it is, so u is cosine x. So b of u would be u squared. So that means that db over du would be 2u. du over dx, well, u is cosine x, so du over dx is negative sine x. So that's why the derivative is 2u times negative sine x. U is cosine x, so it's 2 times cosine x times negative sine x, which gets us to the answer, negative 2 cosine x sine x. Okay. Again, as a shortcut, we can just think of it as we have whatever inside squared, so it becomes 2 times whatever's inside, times the derivative of the inside. 2 more examples. Example 3. Example 3, f of x is 5 times tangent x plus 1 squared. Just to be more clear, is 5 times parentheses tangent x plus 1 close parentheses squared minus sine x. Well, there are 2 terms here. We have the first term, the 5 times tangent x plus 1 squared, and then the second term, negative sine x. We can differentiate them separately. While the second part, the derivative of sine x is just negative sine, derivative of sine x is cosine x, so negative sine x just becomes negative cosine x. Now let's differentiate the first term. We have 5 times whatever's inside, so we can do 5 times whatever. Next, we have tangent x plus 1 squared. Well, the derivative of u squared is 2u, so it's going to be 2u, where u is tangent x plus 1. Of course, 2u is just tangent x plus 1. And then we have to take the derivative of the inside, du over dx. Well, the derivative of tangent x is secant square x. And the derivative of 1 is 0. So we just multiply them together. In other words, if f of x is 5, open parentheses, tangent x plus 1, close parentheses squared, minus sine x, then f prime of x will be 5 times 2 times tangent x plus 1 times secant square x minus cosine x. Let's simplify the last step. 5 times 2 is 10. So it's 10 times parentheses tangent x plus 1, close parentheses. Open parentheses again, secant squared x, close parentheses, minus cosine x. That's the derivative. One final example. B of x is, we are using the product rule this time. There are two terms. The first term is sine of x to the fourth power times the second term cosine of 2x plus 3. Again, product rule. The first term times the derivative of the second term plus the second term times the derivative of the first term. So first term is sine of x to the fourth power. And then the derivative of the second term, well, derivative of cosine u is negative sine u. So it's negative sine of 2x plus 3 times the derivative of the inside. That's the derivative of 2x plus 3 is just 2. Okay. So that's the first term. Plus the derivative plus the second term, cosine of 2x plus 3 times the derivative of the first term. The derivative of sine of u is cosine of u. So it's cosine of x to the fourth power times the derivative of x to the fourth power, which is 4x to the third power. Okay. So to simplify this, the derivative has to be equal to negative 2 times sine of x to the fourth power times sine of 2x plus 3, that's the first term, plus 4x to the third power times cosine of 2x plus 3 times cosine of x to the fourth power. That's it. Okay, so that's it for this video. This is chain rule.